Atomic structure. The structure of an atom is similar to that of the solar system, in which different planets revolve around the Sun. The atom has a nucleus and a number of electrons revolving around it in different orbits. Atomic structure. K-shell. Nucleus. Electron. L-shell. The orbits or shells are usually elliptical and the number of electrons revolving in a shell is definite. The shells are termed as K, L, M, N, O, P. Q-casing the quote is the first shell. The number of electrons can note more than 2, 8, 18 and 2 in K, L, M and N shells, respectively. Electron theory in atom is electrically neutral, but by the application of an external force, the number of electrons present in an atom can be changed. If a neutral atom gains 1 or more electrons, then it becomes negative ion, and if a neutral atom loses 1 or more electrons, then it becomes positive ion. A body having negatively charged atoms and ions is termed as negative body, and a body having positively charged atoms cations is termed as positive body. If the outermost shell of an atom has only 1 or 2 electrons, then these electrons have a small attraction towards their nucleus. Such electrons sometimes leave their orbitary path and become free to move within the substance. Hence these are called free electrons. When an EMF is applied across such substances, then a flow of electrons is set up from the end to the other end of the substance. Such substances are called conductors. The substances which have no free electrons, or through which a flow of electrons cannot be set up under normal conditions, are called insulators. Good insulators have a saturated outermost shell, and they can neither gain nor lose the electrons. Electric current, its effects, the flow of electrons through a conductor from its one end to the other end, is known as electric current. It is invisible, but its presence can be experienced due to its effects. It has the following 5 effects. 1. Physical effect 2. Heating effect 3. Chemical effect 4. Magnetic effect 5. Rays effect. Physical effect. Whenever any part of our body comes in contact with electric current, while we are standing on the ground with bare feet, then we feel an electric shock. Our body is a good conductor of electricity, and that is why when current passes through our body it causes an electric shock. Heating effect. A current carrying conductor becomes heated up. If the conductor has enough resistance, then it produces a good quantity of heat on account of current flowing through it. Electrician, heater, immersion heater, bulb, etc. work on the principle of heating effect of electric current. Chemical effect. Some liquids have a property of producing a chemical change if an electric current is passed through them. The process of chemical change due to the passage of an electric current is called electrolysis. This phenomenon is used in electroplating, etc. Magnetic effect. A carrying conductor produces a magnetic field around. If a direct current is passed through a solenoid or a coil and a soft iron bar is placed inside a coil, then the bar is magnetized. It can attract in pieces electromagnets, electric bell, motors, generators, transformers, etc. Work on the principle of magnetic effect of the electric current. Rays effect. Electric current produces X-rays in a vacuum cathode ray tube. X-rays are very useful in the screening of the human body. Many other types of rays are also produced by electric current, such as cathode rays, ultraviolet rays, laser rays, etc. The difference in the electric potentials of two charged bodies is called as potential difference PD. The potential difference in an electric field is the work done in moving a unit positive charge from the point of lower potential to the point of higher potential. The unit of potential difference is 1 volt if 1 unit work is done in transforming 1 coulomb of charge from a point of lowest potential to a point of high potential. E.M.F. The electrical pressure which sets the electrons in motion is called as electromotive force, that is E.M.F, or in other words, the electric force required to overcome the resistance of conductor is called the electromotive force. For instance, chemical reaction causes a change in the cell or battery in such a way mechanical force causing the conductors to move in the magnetic field sets up an E.M.F. In a generator, electromotive force is the primary cause if the flow of electrons and potential difference is produced by the source EMF. One is the cause, while the other is the effect. But unit of both is same, that is volt. Resistance. The property of a substance which opposes the flow of current is known as resistance. The unit of resistance is ohm and is denoted by the symbol ohm. A wire is said to have a resistance of 1 ohm if it develops 0.24 calories heat when 1 ampere current flows through it for 1 second. Classification of resistances. Classification of resistance is on its ohmic value and purpose resistance. Ohmic value range application: low resistance 1 ohm and below. Armature winding, amateur shunt, contact resistance, medium resistance. Above 1 ohm and up to 100 kilo ohms. Blurbs, heaters, relays, motors, starters, high resistance above 100 kilo ohms. Insulation resistance. Electric current. The continuous flow of electrons is known as electric current. The unit of current is ampere and is denoted by the symbol I. 1 ampere current is said to flow through a wire if 1 coulomb of charge flows per second through any section of wire. Power, the rate of work, is called power. Its unit is watt. In a circuit with 1 volt pressure, the quantity of electric current produced represents 1 watt of power. Power is obtained from circuit voltage multiplied by current. If voltage is V and current I, then power P equals VI watts. The voltage EMF of an electric source or a potential difference across a resistor is called the voltage. The unit of potential difference is volt and its symbol is V. Classification of voltages. The voltage is classified as follows. A low voltage up to 250 volts. The medium voltage minus 250 volts to 650 volts. C high voltage minus 650 volts to 11,000 volts. D extra high voltage minus 11,000 volts to 220 kilovolts.